This is my beginning algebra course. In the next class, you're going to take test number 3, and today we're going to prepare for that exam. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. As I mentioned in previous classes, you cannot take a mathematics test and pass it without studying for the test. Doing the homework and the class problems will make you ready to study for the exam, but it's not enough to pass the exam. You have to do some studying. The problem is, it doesn't matter how many times you tell students to study for the exam, they're not going to do it. So in order to force you to do at least some studying, I'm going to give you a practice test for homework. And we're also going to do a practice test right now. So 2 practice tests. And again, as I mentioned in previous classes, there are 2 reasons for these practice tests. Number 1, to show you what the tests are going to be like. So you can't take test number 3 and say, well, I didn't know it was going to be like this. And number 2, it's to, again, force you to at least do a little bit of studying. And, taking these practice tests is not going to guarantee that you're going to get an A, but hopefully it'll ensure that you at least pass the test they're going to take in the next class. Now, if you want to get an A in the test, you have to go back into the description section of all the videos and look at the notes and do your homework problems and make sure you know how to do every type of problem. That'll ensure you get an A. Okay, so let's go into this practice test here. You see we have version 1. You're going to take version 2 of practice test 3 for homework. And so let's get started. And I want to remind you, when we do these practice tests, or this practice test together in class, here's what I want you to do. I want you to attempt these problems if you can do them on your own. Don't just watch me do the problem if you know how to do it on your own. Just do the problem and then fast forward to where I give you the answer down here and see if you did it correctly and just go on to the next problem. You only need to watch me if you forgot how to do the problem. Now, if you completely forgot how to do this problem, then obviously you're going to want to watch me do it. But if I start to do it and you remember how to do the problem, then immediately stop the video and do the rest yourself. If you can do the problem on your own, do it. Don't just watch me do the problem. So let's get started with number 1. Now, this is an equation with a square root. Whenever you have an equation with a square root, you want to try to isolate the square root. So I'm going to subtract 2 from both sides of the equation. And then I'm going to multiply both sides by 3. Now, be aware that some equations, when you have more than one root, it's hard to isolate the root. So just be aware of that. But if you only have one root, you can usually isolate that root. So now we found root x. We know what root x is. Problem is, we don't want root x. We want x. So we have to get rid of that root. So what we're going to do is square both sides, because that's the opposite of square rooting, is squaring. And I guess you don't really need parentheses on the right side of the equation. And that's going to get rid of the root, so you're left with x is equal to whatever 15 to the second power is, and that just happens to be 225. So if you got that answer, good job. Okay, go ahead and try number 2 if you can, if you forgot how to do that problem. What you want to do is put everything on the left side of the equation so you have a positive coefficient on the x squared term. We prefer a positive coefficient. Then you want to factor using your greatest common factor method. And maybe I should show you these. Remember, there's 6 types of factoring that we learned. You're going to learn, or you're going to use the GCF factoring method to solve this. And you're going to see the solution. So go ahead and try that. Pause the video. And when you come back, we'll do it together. If you are not sure how to do it, then let's go ahead and jump into this. So subtract 15x from both sides. Then we're going to factor out a greatest common factor, and I see that 5 goes into 10 and 15, so I'm going to factor out 5, and they both have x's. The biggest number of x's that are common to all of them is x, so that's my greatest common factor, 5x. 5x times what is equal to 10x squared? Well, that's going to be 2x. And 5x times what is equal to negative 15x? Well, that's just going to be negative 3. All right, so if that's a little bit too much for you, you can just do the numbers first. 5 times what is equal to 10? That's 2. Then x times how many x's is equal to x squared? You can do it individually. 5 times what is equal to negative 15? And then x times how many x's is equal to x? That's just x times no x's. So at this point, you might be thinking, well, why do we do that? Well, we can see the solutions now. If 5x is equal to 0, then that will make the equation true. And if 2x minus 3 is equal to 0, that will make the equation true. Because we're multiplying this yellow expression by the blue expression. Because there's parentheses, that means multiplication. If we multiply the yellow and the blue and we get 0, that means that either the yellow or the blue, or both of them, have to be 0. Remember, if you take some random number like 7 and you multiply it by 0, it's going to be 0. Anything multiplied by 0 is 0. So if the blue or the yellow is 0, then that's going to make the equation work. It's going to be equal to 0. So we want to make the yellow 0, so we set it equal to 0. What x value makes it 0? Divide by 5 and you find that if x is 0, then 0 times 5 is 0. 0 times all this is 0, so that works. I know you're probably thinking, well, I'm overanalyzing this, but I'm just explaining why this works. If we solve for x in this equation, we get 3/2, and what that means is that if you plug in 3/2 to the blue, you get the blue becomes 0. And so 0 times some number is 0. It works. You don't have to think about it that way every time you do the problem. You just have to know how to do the problem. Most students, they just go through the motions and solve the problem. You don't have to be able to think about it, why it works every time. Okay, so if you got the answer there, good job. Let's go to number 3. So again, you want to attempt number 3, see if you can do it on your own. We're going to be using the second type of factoring, the quadratic. But the problem is, this doesn't look like a quadratic, you see, because it's not in standard form. And if you don't recognize this as a quadratic equation, then I'll tell you something, you're not going to solve it, that's for sure. A lot of students, they see these equations and they don't recognize them as quadratic equations, so they've got no hope of solving it. In order to solve a quadratic equation, you have to use special methods because quadratic equations are special equations. But you won't be able to use those methods if you don't even recognize it as a quadratic. So how do I know it's a quadratic? Well, I've got a variable squared, a variable that's not squared, and a regular number with no variable. That means quadratic. But how come that we don't really recognize this? It doesn't look very familiar. Well, the reason it doesn't look familiar is because it's not in standard form. We have to put it in standard form before we can solve it. So to put it in standard form, I put everything on the right side of the equation. The reason I put it on the right side is because I want a positive coefficient here. So now we can kind of recognize it as a quadratic. But we've got another problem. We have a coefficient here, so that complicates things. So we cannot ask, we are going to ask what two numbers multiply to 16, but those two numbers are not going to add up to negative 32. Why? Because this 7 complicates things. So the way that we're going to do this, now that it's in standard form, and again, you have to put it in standard form in order to be able to solve it. The way we're going to do this is we're going to ask what two numbers multiply to 7x squared. That's just going to be 7 times 1, or 7x times x. And then we ask what two numbers multiply to positive 16. Well, I'm just going to try 4 and 4. I don't know if that's going to work. And they multiply to a positive and they add up to a negative. So they're both going to have to be negative. A negative times a negative is a positive, and a negative plus a negative is a negative. Okay, so now we have to FOIL. Remember FOIL, F-O-I-L. We have to FOIL that out. F of FOIL is 7x squared. O of FOIL is negative 28x. I of FOIL is negative 4x. And L of FOIL is 16. Now we don't really have to do the L and the F because we already know that's going to work. We designed it that way. What we really care about is the O and the I. Do those add up to get negative 32? And surprise, they do. That was kind of just luck. I chose the right ones on the first try. Usually you have to try it maybe 1 or 2 times before you get the right combination of numbers. So what that means is we now can set 7x minus 4 to 0, and we can set x minus 4 equal to 0. Again, that's what you need in order for the equation to work. The green has to be 0, or the purple has to be 0. If you're multiplying 0, you have to get to 0. One of those has to be 0. Whenever you multiply by 0, you get 0. So now we're going to solve, and we get 4/7. And over here we get 4. So if you plug in 4 to the purple, you make 0 in the purple. The purple becomes 0. You plug in 4/7 to the green, and the green becomes 0. So that's why we know those work. Again, it might sound like I'm overanalyzing this. You don't have to think about it in those terms. You just have to solve it. You just have to know how to solve it and solve it. So if you got that answer, good job. Again, if you start to figure out how to do the problem, don't just watch me do it. Just take over and do the problem yourself. Okay, so now we're going to do factoring by grouping. Number 4 is going to be factoring by grouping. So again, go ahead and attempt that problem. If you think you can do it, go ahead and do it. You're going to have to put everything on the left side of the equation. And you're going to have to write everything in descending order of powers. So go ahead and attempt this problem. When you come back, we'll do it together. If you're not sure how to do it, then we'll go ahead and do it right now. I added x squared to both sides, and that took this negative x squared, put it on the other side. And notice that I ordered everything by descending order of powers. So now we're going to factor this group here, and then we're going to factor this group here. So I'm going to factor out an x squared from the yellow group. And I'm going to factor out a negative 4 from the blue group. So again, this is my blue term and my yellow term. And so again, to see why that works, you just distribute back. X squared times x is x cubed, and x squared times 1 is x squared. Same thing with the blue part. Just use the distributive property. So now, do you see how we have an x plus 1 in both of these terms? We have an x plus 1 there, and we have an x plus 1 here. So we have an x plus 1 that's common to both of these terms, the yellow and the blue. So what I'm going to do is I'm going to factor out that whole x plus 1 from both of those, and you're going to be left with x squared minus 4. You see the x squared minus 4 that was left when I factored out the x plus 1. The problem at this point is x squared minus 4, that's the difference of two squares. So now we're doing DOTS, difference of two squares. So we're doing grouping and difference of two squares in this problem. Remember, we had that class on combined types of factoring. So what number multiplied by itself is equal to 4? Well, if you said 2, you're correct. And remember, whenever you have difference of two squares, you always write a plus and a minus. So we have this green factor here and the orange factor, we have this purple factor. What we want in order to make this equation true, in order to make all this stuff equal to 0, that's what we're trying to do. We're trying to find the x value that makes this equation work. So we want all this to multiply so it equals 0. So what we're going to try to do is set the green equal to 0, figure out what x value would make that green 0, and also what x value would make the orange 0, and what x value would make the purple 0. That's what we're trying to do here. So all we have to do is solve those equations, and they will tell us what x values will make those colors 0. So obviously we have x is equal to -1, or x is equal to 2, or x is equal to -2. And there you go. Let's just double check all that. Everything looks good. So if you plug in -1 to the green, then it makes that 0. So if you multiply 0 times all these numbers, whatever those numbers are, then it's going to, the product's going to be 0. That's what we want to make the equation true. If you plug in 2 to this orange expression, then it's going to make the orange 0, and it's going to multiply into all these and make this 0, so that works. You plug in -2 to the purple, and so on and so forth. So that's why those are solutions to the equation. All right, so if you got that one right, good job. So now we're going on to, whoops, I think we're going up here, number 5. Now we have another equation with a square root. Whenever you have an equation with a square root, you want to isolate the root, get it by itself, and then you're going to square both sides to get rid of that root. So I have to warn you, though, this problem is going to be kind of a trick problem. So go and attempt number 5 if you want to give that a go. Pause the video, and when you come back, we'll do it together. If you're not sure how to do it, then let's do it together now. I'm going to subtract 1, and I'm going to multiply both sides by -4. Now, I said this is a trick problem, right? Well, here's the trick. It's impossible for the square root of a number to be a negative. All right, so that's impossible. Why is it impossible? You know, a lot of students, they will say, well, wait a second. If you take the square root of 9, for example, just using 9 as an example, wouldn't that be plus or minus 3? Because you're asking what number times itself is equal to 9, right? Well, 3 times 3 is 9, but -3 times -3 is also 9. Okay? 3 times 3 is 9, but -3 times -3 is also 9. So isn't there 2 solutions? It should be plus or minus 3. Well, the answer is no. And the reason is, mathematicians have defined this square root notation to only produce a positive. Now, I know that's not a very satisfying answer, but this notation, again, is just defined, meaning whenever you hear somebody say this is defined as this, in the math world, what that means is mathematicians just decided that that's what it's going to be. So I know that's not a satisfying answer, but that's the answer nonetheless. So it's impossible for the square root of a number to be a negative. So what do? You say no solution. And you're done. Now let's say that you didn't know that and you just kept going with the problem. And the next step would be to square both sides, and you end up with y is equal to 400. Then you might say, well, I found the solution, it's 400. But the problem is, if you plug that solution back in, the square root of 400 is 20. 20 divided by -4 is -5. -5 plus 1 is -4. -4 is not equal to 6. So that's an extraneous solution. It doesn't work. You're not required to find that extraneous solution. You can just say no solution and you're done. Okay, so number 6, we have another equation with the square root. and I want you to isolate this yellow root, get it by itself. It's not by itself because the 4 and the -5 are next to it. Get the yellow part by itself. When you're solving the equation with a square root, if you can, you always want to isolate the square root. So try number 6. When you come back, we'll do it together. If you're not sure how to do that problem, then we'll do it together. Add 5 to both sides. And divide both sides by 4. And at this point, we've isolated the square root. It's isolated because it's by itself now. So now we want to get rid of that square root because we can't isolate the x. We want to get the x by itself, but we can't do that because it's inside that square root. We have to get rid of that square root. So we're going to do the opposite of square rooting, which is squaring both sides. And that gets rid of the square root on the right side of the equation. And on the left side, we have 7/4 to the second power just means 7/4 times 7/4. So that would just be 49 over 16. 7 times 7 is 49. 4 times 4 is 16. Again, 7/4 times 7/4. When you're multiplying fractions, you just multiply straight across. That's something that you should know by now. Okay, so now we have a little bit of arithmetic to do. We have to subtract 3 from both sides. And at this point, again, a lot of students who didn't really have a good elementary school math education or a good arithmetic curriculum, they don't really know what to do. They'll get stuck on that point. Remember, you write 3 as over 1. You can always write any fraction as over 1. Multiply both sides of this fraction by 16, and you get 48 over 16. 3 times 16 is 48. 1 times 16 is 16. So now we have a common denominator. That's the point of that. And 49 over 16 minus 48 over 16 is 1 over 16. Again, that's all stuff that is considered prerequisite knowledge. Most beginning algebra teachers are not going to show you that. They're just going to assume that you know how to do that. Okay, so now we want to multiply both sides by -6. So if I do that, it's going to cancel out the negative and the 6 on the right side. Then I'm going to end up with this. And again, most teachers are just going to write the answer. It's going to be -3/8. But again, if your arithmetic education wasn't that great, we're multiplying 1 over 16 times -6. You just write -6 over 1, and now you're multiplying fractions. Multiply straight across, and straight across here. You end up with -6 over 16. Reduce that, and you get -3 over 8. Again, that's all stuff that you should know. Okay, let's go on to the next problem here. If you got that answer, good job. On to number 7. So now we have an equation with square roots. The problem is there's 2 square roots. So we can't isolate the root because there's 2 of them. So we can't really do that. We'd like to combine the roots if we can, but we can't really combine these roots. I guess you could kind of say that they're isolated because they're alone on each side of the equation, but the way that you want to do this is just square both sides of the equation. That's the only thing you can do. So I'm going to rewrite and square both sides of the equation. That's going to get rid of the square root symbols, and you're left with the following. Now again, if you know where I'm going with this, you can try this on your own. Whenever you feel like you can do the rest of the problem, do it. Don't wait for me to do it for you. You can check the answer when I'm done, but do it on your own and find your own answer. Now, at this point, we're stuck. We're dead in the water. We can't do anything unless we recognize that this is a quadratic equation. A lot of students would get stuck at this point, and they'd look at that and think, I don't know what to do. This is a quadratic, which means it's a special equation that requires special methods to solve it. You can use those methods, you know those methods, but if you don't recognize it as a quadratic equation, then obviously you're not going to be able to use the special methods. Now, how do I know it's a quadratic? Well, because it has a variable squared, a variable that's not squared, and a number without a variable. Okay, so I know it's a quadratic equation. But I cannot solve this unless I put it in standard form. So I'm going to subtract 18 from both sides, and now it's in standard form, and we can recognize that it's a quadratic, whereas here we couldn't really recognize it. So now, this should look very familiar to you. We solve quadratics in this course by factoring. You're going to learn other methods in upper mathematics courses, but the factoring is the only method we're going to learn in this course. So we ask ourselves, what two numbers multiply to negative 18? What are two numbers that when you multiply them together you get negative 18, but they add up to 7? What are two numbers that you multiply to get negative 18, but those same two numbers you add them up and you get 7? Think about that. Well, if you said plus 9 and minus 2, you're correct. So all we did was just change the form of this expression to this blue expression. Why did we do that? Because now, just looking at this blue expression, we can see the solutions. We want the green expression to be 0 or the blue expression to be 0. Why is that? Well, we talked about that up here. If the green expression is 0, then you have 0 times some number is 0, and it works. If the blue expression is 0, then you have 0 times some number is 0, and the equation works. So we can see what the values are going to be. If we let x equal 9, or x plus 9 equals 0, or x minus 2 equals 0, we can find the x values that will make the green 0, or the 1x value that will make the green 0. Now we can find the 1x value that will make the blue 0. So there you go. So those are the solutions. If I plug in negative 9 to the green, don't I get 0 on the green part? So the green multiplies into what would become negative 11, and we'd have 0. If I plug in 2 to the blue part, we get 0 times 11, and again we get 0. So those solutions work. Now this may seem like, again, a convoluted explanation, but you don't have to know any of this explanation. You don't have to think about this in this much detail. You just have to know how to do the problem. Okay, so at this point we have to check both of these solutions. When you have equations with square roots and the square root equations become a little complicated, which in this case it does look a little complicated, you do have to check your solutions. So let's plug in 2. 2 squared is 4. 2 times 7 is 14. 14 plus 4 is 18. So we have root 18 is equal to root 18. That works. Now let's plug in negative 9. That was the other solution. Negative 9 squared is 81. Negative 9 times 7 is 63. 81 minus 63 is 18. So root 18 is equal to root 18. So that works. Now, if you plugged in something and you got a negative under the root, then that would mean it's an extraneous solution. You can't have a negative under a root, okay, because that's actually an imaginary number. Again, that means that there's some number. For example, if I ask you what is the square root of negative 4, what you're asking is what number times itself is equal to negative 4. Well, that's impossible. You can't have a number times itself equal to a negative. I know that stuff seems a little complicated, but the most important thing is you know the basic idea of how to solve these. So if you got those solutions, good job. Let's try number 8. Now we have an equation with a square. Not a square root, but a square. The good news is that you solve this equation pretty much the same way that you solve these other equations. You isolate the square, get it by itself. But then instead of squaring both sides to get rid of the square root, you square root both sides to get rid of the square. I know this stuff is sounding kind of convoluted. So go ahead and try number 8. Isolate, get y squared by itself. You can at least do that. And when you come back, we'll do it together. All right, we're back. We're going to add 3 to both sides. Then we're going to divide both sides by 7. And so we isolated the square. We found y squared, but we don't want y squared. We want y. So we're going to have to get rid of that second power. So we're going to do the opposite of squaring, which is square rooting. But what students almost always forget is to write a plus or minus. Whenever you square root both sides of an equation, you have to put a plus or minus on the side that's opposite of the variable. And why is that? Well, because if you have a positive number squared, you get a positive number. But if you have the same number negative squared, you also get the positive number. For example, if you have, let's say you have 5 squared, that's 25, right? But negative 5 squared, that's also 25. So there's 2 solutions. Okay, so at this point, the square goes away. We're just left with y. And now we're going to do a lot of math in order to simplify this. We have to pull out the perfect square factor out of 18, and we also have to get rid of the root in the denominator. The denominator cannot be inside the root. So there's a lot we can do here. You can skip a lot of steps here. In previous classes we showed how to do every single step, but I'm not going to do that here because you need to start jumping forward with that stuff. So I'm going to pull out a perfect square factor in the numerator. So 18 is 9 times 2. Pull out the 9 as a 3. The 2 stays in. Then I'm going to multiply both sides by root 7. So then I get 3 root 14 over 7. And that is the final answer. There's 2 answers. There's positive 3 root 14 over 7. And there's negative 3 root 14 over 7. So when you multiply root 7 by root 7, it just becomes 7. And root 2 by root 7, it becomes root 14. These are all just review concepts. Now, we could show all the work that's involved with that, but again, you can't keep doing that. You got to learn how to do that quickly, or this stuff is just going to become too tedious. When you're doing an exam and you're pressed for time to get the exam finished, you have to skip some steps sometimes. All right, so if you got that answer, good job. Let's try number 9. Number 9, we're going to use the GCF factoring out a greatest common factor. And when you come back, we'll do it together. If you're not sure how to do this problem, let's go ahead and do it together. We're going to factor out a 3 and an x. So in order to see why that works, you can multiply back using the distributive property. 3x times 4x is 12x squared, and 3x times negative 9 is negative 27x. So at that point, we know that 3x can be equal to 0, or 4x minus 9 can be equal to 0. Because if the yellow is 0, then the equation works. If the blue is 0, then the equation works. So divide both sides by 3, and we get x is equal to 0. Solve for x, and we get 9/4. If you plug in 9/4 to the blue, you get 0, and that makes the equation work. If you plug in 0 to the yellow, you get 0 for the yellow, and that makes the equation work. So if you got that answer, good job. Okay, let's go on to number 10. We have an equation with a square. So you're going to isolate the green square. Get it by itself. It's not by itself because the negative 8 and the 2 are next to it. So go ahead and try that problem. And after you isolate the square, you're going to square root both sides, remembering to write a plus or minus on the side opposite the variable, and see what you can do. When you come back, we'll attempt the problem together. All right, we're back. We're going to add 8 to both sides and divide both sides by 2. And so we isolated the square. The square is now by itself on one side of the equation. But in order to get to that x, we need to get rid of the square so we can get inside to that x. The opposite of squaring is square rooting. So I'm going to square root both sides. And remember, you have to write a plus or minus symbol on the side opposite the variable, plus or minus. Maybe I should just keep that black. There we go. Okay, now that gets rid of the square, so we have x over 4 plus 5. And what number times itself is equal to 1? Well, that's just 1. So we have plus or minus 1. So what this means is that x over 4 plus 5 can be positive 1, or x over 4 plus 5 can be negative 1. So solve over here, and we get x is equal to negative 16. Solve over here, and we get x is equal to negative 24. I just double check that everything looks right. And we don't really have to check for an extraneous solution there. If you end up with something like x squared is equal to a negative number, that's impossible, so you can just stop there. But I don't think I gave you any of those problems in the main part of that class, although you did see some of those in subsequent classes. Okay, so if you got those answers, good job. Let's go on to number 11. Now we have an equation with fractions. Whenever you have an equation with fractions, you have to find a common denominator for all the fractions. Problem is, these don't look like fractions. But we're going to turn them into fractions, and then we're going to end up with a fraction is equal to another fraction, and the denominators are going to be the same, which means the numerators must be the same. So you can just get rid of the denominators and solve for the numerators, or solve with the numerators. So we're going to write 2x as 2x over 1 and 1 as 1 over 1. Then they look like fractions. Now again, attempt this problem. If you think you can do it, go ahead and attempt the problem. So stop the video. If you're starting to figure out how to do it as I'm showing you this, stop the video. Don't let me just do it for you. You're gonna learn 10 times more if you actually do this problem yourself. The purpose of this practice test and the practice test given for your homework is to help you study for the test. The best way to study is to do problems. Okay, so now I'm going to multiply. We see that 10 is probably the lowest common denominator. I'm going to multiply both sides of this fraction by 10, and I get, I get 20x over 10. Multiply both sides of this fraction by 10, and I get 10 over 10. Multiply both sides of this fraction by 2, and I get 6x over 10. And I don't have to do anything with that other fraction because it already has 10 in the denominator. Okay, so now I'm going to combine the fractions on the left side of the equation because they have a common denominator, so I can do that. Combine the fractions on the right side of the equation because they have a common denominator. I can do that. And now it's very important to understand where we are at this point. I have a fraction that's equal to another fraction, and the denominators are the same. The only way that those fractions could possibly be equal is if the numerators were equal. So you can just get rid of those denominators, and there we are. Subtract 6x from both sides, add 10 to both sides, divide both sides by 14, and we have x is equal to 1/2. So if you got that solution, good job. All right, so again, you should not be just watching me do all these entire problems. You need to pause the video periodically and try to do some of it yourself. If you can't do all the problem yourself, that's okay, but you should be attempting at least parts of these problems. So if you know how to do problem 12, go ahead and attempt it. If you forgot how to do it, what you're going to do is put everything on the left side of the equation. You're going to use your GCF, factor out a greatest common factor. Then you're going to be left with this expression over here, an expression that looks like this. That's the sixth type of factoring that we did. And then you're going to factor that like you would factor a quadratic expression. And see what you can do, and when you come back, we'll attempt it together. All right, we're back. So 10x to the 5th. Now again, if you got stuck, that's okay. We're going to put everything on the left side of the equation. It's okay to get stuck when you're doing a practice exam. It's not okay to get stuck when you're doing the actual exam. We're going to factor out 10 because 10 goes into all those and x goes into all those. So we're left with x to the 4th power minus 4 x squared minus 21. Now this is a quadratic. It's an expression similar to a quadratic. It's not technically a quadratic, but we're going to factor it as if it were a quadratic. So because it's like a quadratic, we're going to write two sets of parentheses, and instead of x, we're going to write x squared because it's x to the 4th power, you see. And we're going to ask, because there's no coefficient here, we can solve this pretty easily, or factor it pretty easily. What two numbers multiply to negative 21 and add up to negative 4? What two numbers multiply to negative 21 and add up to negative 4? If you said negative 7 and positive 3, you're correct. We factored it, and that's going to help us solve the equation. So what that means is that 10x can be equal to 0, or x squared minus 7 can be equal to 0 in order for the equation to work. It has to be equal to 0. Or x squared plus 3 must be equal to 0 for the equation to work. So we're trying to figure out the x value that will make the equation work. That's called a solution of the equation, an x value that makes the equation work. We're trying to find those x values. There's going to be multiple x values for this problem. So divide by 10 and we get x is equal to 0. 0 is one of the solutions. So if the yellow is 0, we plug in x to that yellow and we get 0, so that makes the equation 0, because again, the parentheses mean multiplication. Here we're going to have to solve an equation with a square. This is an equation with a square. So we have to solve it just like we would any other normal equation with a square. We isolate the square, get it by itself. So we do that by putting the 7 on the other side. Now the square is isolated. Well, now we have to square root both sides. And whenever you do that, remember, you always put a plus or minus on the side opposite the variable. So now we have x is equal to plus or minus root 7. And those are the two solutions produced by that factor. So if you plug in root 7 into this blue expression, you get 0. And if you plug in negative root 7, you also get 0. Now over here, we're going to do the same thing. we're going to try to isolate the square, but over here, if you try to isolate the square, you see x squared is equal to a negative. That's impossible. You can't square a number and get a negative, so that's not going to produce a solution. It would produce what's called an imaginary solution, but we don't care about imaginary solutions. We're not at that level of mathematics. Okay, so our three solutions are 0, root 7, and negative root 7. So if you got that answer, that was very good. That was a challenge problem. All right, so you might be thinking, well, this stuff is really hard, and I don't know how to do this stuff. Well, now you do. That's the point of this practice exam. It's to jumpstart your mind. And if you need more practice with this stuff, which you should need more practice with this stuff, again, this doesn't guarantee that you're going to get an A in the exam. It just forces you to do at least a little bit of studying, you see. If you want to get an A in the exam, you have to make sure you know how to do all the problems. You have to go back and do all the problems that we did in the class and the homework, and make sure you know how to. You don't have to do all of them. You just have to make sure you know how to do all of them. Okay, so now we're going to do another problem with fractions. If you think you can do this, go ahead and do it. When you're solving an equation with fractions, you have to get a common denominator, and you're going to end up with one fraction is equal to another fraction. The denominators are going to be the same. Get rid of the denominators, set the numerators equal to each other, and solve. So go ahead and do that, and when you come back, we'll attempt this together. All right, we're back. If you're not sure what I mean, you want to start off by writing fractions there. And turning those into fractions, that alone might help you to solve this problem. So you can take it from there if you know how to do it now. If you're still not sure, we want x in all these denominators. So I'm going to multiply both sides of this fraction by x. And I'm going to multiply both sides of this fraction by x. So now you can see we're getting somewhere because all these fractions have the same denominator. And I may have mentioned there's faster ways to do this, but the faster ways are generally more difficult to understand. So the purpose of this is to educate, not to do it necessarily the fastest way. Okay, so now we're going to add these expressions because they have a common denominator, so we can add them. Add those fractions together on the left side of the equation. And now, at this point, we have two fractions that are equal to each other. And they have the same denominator. So that means the only way for those fractions to possibly be equal is for the numerators to be equal. So we can just get rid of the denominators. But now we have a problem. We don't know how to solve this. What in the world is this thing here? Well, that's a quadratic equation. It's a special equation, so it requires special methods to solve it. Also, it requires us to put this in standard form. So if we don't recognize it as a quadratic, then we're not going to be able to put it in standard form, and we're not going to be able to solve it. So recognizing an equation as a quadratic is extremely important. If you can't do that, you have no hope to solve this problem. Now, the reason I know it's a quadratic is because I have a variable squared, a regular variable, and a number that has no variable. To put it in standard form, I'm going to put everything on one side, and I would prefer to keep this coefficient positive, so I'm going to put everything on the left side. You can factor it if it's negative, but that would be, I didn't even show you how to do that in this course because that's just unnecessary. You can make it to where it has a positive coefficient. Okay, so now it's in standard form, right? This is standard form. Everything's on the same side. So now that it's in standard form, we recognize it, and we can use the factoring method. What two numbers multiply to 25 and add up to 10? Well, that's just going to be 5 times 5 is 25, and 5 plus 5 is 10. And now you see we have one solution, x is equal to negative 5, but just to keep the same method here, we want to know what makes x plus 5 0. Well, if you plug in negative 5 to x plus 5, it makes it 0. So that makes both of these factors 0. And so if you multiply them together, you get 0. So that makes the equation work. Now, when we have equations with fractions, we want to figure out if there's any extraneous solutions. If you plug in an x value in a denominator and it makes the denominator 0, that's extraneous because you can't have 0 in the denominators of fractions. So whenever you're solving an equation with fractions, you have to plug the answers back in to make sure that no denominators become 0. But you can see that plugging in negative 5 here is not going to make that denominator 0. So we have no extraneous solutions. Remember, extraneous solution means it's not a solution. It just looks like a solution. So if you got that answer, good job. Now we're going to do another equation with a square. Again, you have to isolate this square. Get it by itself. It's not by itself because a 2 is next to it. So isolate that square. Once you isolate the square, then you're going to square root both sides, remembering to write a plus or minus on the side opposite of the variable, and see what you can do. Attempt number 14, and when you come back, we'll do it together. All right, we're back. So I'm going to get the square by itself by subtracting 2 from both sides. So now I isolated the square. Now I'm going to get rid of the square because we can't get to that x unless we get rid of the square. So I'm going to square root both sides. And remember, whenever you do that, you have to write plus or minus. It's one of the most common mistakes that students make. They forget to write a plus or minus. So now square rooting gets rid of the square. And now all I have to do is just solve that equation. So I'm going to subtract 7 from both sides. And you need to realize that we can write it like this if I subtract 7 from both sides. But we can also write it like this. It doesn't matter. All right, so now things are going to get a little bit weird because we have to divide by negative 2. And this is something that can be kind of confusing for students. Because it's going to be kind of a weird sign issue. Divide by negative 2. If you look in a textbook, you're probably not going to see this type of answer in the back of the textbook. Normally textbooks have answers in the back of the textbook. What you're going to see for the answer is probably something like this. But why is that? I thought the answer was this. Why is it this? Well, because when you divide by a negative, it changes all the signs up here. It's like it's taking negative 7 and dividing by negative 2. Well, then it becomes positive 7 over 2, right? If you have some number, let's say you have whatever, something here, we'll call it smiley face, and you're subtracting 7, you divide by negative 2, that negative you can kind of put it up here and change these signs if you want to. By the way, this is not wrong. You can write that. There's nothing wrong with that. So that's what they do is they change this sign to a positive and they change this sign to a positive because like I said, both signs are going to change, so this is going to change to a positive, but what students have trouble understanding is why is it that this doesn't change? Well, that's a plus or minus. If you multiply by a negative 1, it just stays plus or minus. If it's plus, it becomes minus. If it's minus, it becomes plus, but that's still plus or minus. I know that seems kind of complicated, but just be aware that you're probably going to see this answer in a textbook. So if you got that right, good job. Okay, on to number 15. We have an equation with fractions. You want to get a common denominator, set the fractions equal to each other. If the denominator is the same for both fractions, then you can get rid of the denominators, and then we'll see where we are at that point. So try number 15, and when you come back, we'll do it together. All right, we're back. So I'm going to I'm going to multiply this fraction, both sides of this fraction, by y. And I'm going to multiply both sides of this fraction by 3. And I'm going to multiply both sides of this fraction at the far right by y squared. So we get 11y over 3y to the 4th power plus 24 over 3y to the 4th power equals negative y squared over 3y to the 4th power. Now, did I do it right? Well, the way you figure out if I did it correctly is by looking at the denominators. Are they all the same? They are. So just be aware that a lot of students, they multiply the denominators, but they forget to multiply the numerators. Okay, if you do that, then that really demonstrates a lack of understanding of the basic principles of mathematics. So you want to really, not do that. If you multiply the top, you have to multiply the bottom, right? Okay, so now we can combine the fractions on the left side of the equation because they have a common denominator. Whoops, forgot to write 3y to the 4th. And so now, again, it's very important to understand where we are at this point. We have two fractions that are equal to each other, and the fractions have the same denominators. So the only way that they could be equal is if the numerators were equal. So now all we have to do is solve that equation. The problem is that's a quadratic equation. You have to recognize it as a quadratic equation so that you can use the special methods that we learn to solve it. So now that we know it's a quadratic, we're going to put it in a more recognizable form, standard form, because you can't solve it unless you put it in standard form. And then we're going to solve that equation by factoring. So we don't have a coefficient in front of the y squared term, so this is going to be pretty easy. What two numbers multiply to 24 and add up to 11? What two numbers multiply to 24 and add up to 11? If you said 8 and 3, you're correct. So now, I'm going to shrink some of this stuff because I'm running out of room. So now we know that either y plus 8 has to be 0 in order to make the equation true, or y plus 3 has to be 0 in order to make the equation true. So that means that y must be equal to negative 8, or y must be equal to negative 3. Now, if you plug those in, does it make the denominator 0? Of course not. So we don't have to worry about extraneous solutions. Remember, whenever you have an equation with fractions, you have to worry about the solutions making the denominators in the original equation 0. And so neither of these solutions make the denominator 0. So if you got those answers, good job. All right, on to number 16. We have another equation with fractions. If you want to go ahead and attempt that, go ahead. It's the same principle. When you come back, we'll do it together. All right, we're back. So the common denominator is 8x, but before we even try to get a common denominator, I'm going to turn these into fractions, all of them. 2 didn't look like a fraction, but now it does. I'm going to multiply both sides of this fraction by x, and both sides of this fraction by 8, both sides of this fraction by 8x, and this one I don't have to change because it's already 8x. Now we're going to combine these fractions at the left because they have a common denominator. And we're going to combine these fractions. And we have two fractions that are equal to each other, and the denominators are the same. So that means the only way that this could possibly work is if the numerators were equal. Then we just have to solve for the numerators, and we get 17x is equal to negative 37. So x is equal to negative 37 over 17. And there's no way that that's going to make a denominator 0 in the original equation, so you don't have to worry about that. So if you got that answer, good job. Okay, on to number 17. You're going to put everything on the left side, factor a greatest common factor, and factor the quadratic that results, and see where you go with that. So try number 17. When you come back, we'll do it together. All right, we're back. Add 4x to the fourth to both sides of the equation. Then factor out 4. These numbers are kind of big, sorry about that. And factor out x squared. I think it's going to be 14, and I think it's going to be 48. Sorry about those big numbers. Usually I don't give you such big numbers because they're kind of a pain to deal with. That looks right. So now we have a quadratic expression. So we can factor that. We factored out of GCF, which is 4x squared. Now we can factor the quadratic. What two numbers multiply to 48 and add up to negative 14x? Or negative 14, I forgot to put my x there. What two numbers multiply to 48? What two numbers multiply to 48 and add up to negative 14? So that's going to be negative 6 and negative 8. So what does this tell us? It tells us that if 4x squared is equal to 0, or if x minus 6 is equal to 0, or if x minus 8 is equal to 0, then the equation is going to work. Here we have a lot of math to do here, but I don't really want to do all that math, and it's not really necessary. The only value that is going to make that work is 0. So you can just write 0. You don't have to show all that work. X is equal to 6, or x is equal to 8, solving those equations. All right. We don't care about extraneous solutions for this particular equation, only when we have roots, fractions, or squares. Technically we have squares, but this is just not the type of problem where we'd have to deal with that. So now let's try 18. You're going to use the factoring by grouping method. You're going to put everything on one side. It's already on one side, so you don't have to do that. And try to see if you can remember how to group. And when you come back, we'll do it together. All right, we're back. So I'm going to take this group here and factor out x squared. And this is where things get a little weird. There's not really anything to factor out here. But if I treat that, if I kind of pretend like I'm factoring out 1, 1 is always a factor of everything. So I can pretend that I'm factoring out 1. So that was kind of a trick problem. If you got tricked by that, then it's okay. But I have my green group and I have my yellow group. Now, isn't it true that x plus 4 is common to both those? So I'm going to factor out x plus 4 out of that whole entire thing, and I'm going to be left with x squared plus 1. So now, if x plus 4 is equal to 0, or if x squared plus 1 is equal to 0, then that'll make the equation true. So if we solve here, we get x is equal to negative 4. If x is equal to negative 4, it'll make the blue expression 0, and that'll make the equation work. All right, now here I'm going to try to solve for the square, isolate the square, but immediately you can see we have a problem because a square cannot be equal to a negative, so that's not going to produce a solution. All right, so if you got that answer, negative 4, good job. Let's try number 19. If you can do this problem, go ahead and attempt it. Put everything on the left side, factor by grouping. I know this is going to be a grouping problem because there's 4 terms. Usually if there's 4 terms, it's going to be grouping. So try number 19. When you come back, we'll do it together. All right, we're going to start by putting everything on the left side of the equation. I'm going to factor this group here. Factor out a GCF. I'm going to factor this group here. Factor a GCF out of that. And then I'm going to factor out b minus 9 from both of those. So now, if b minus 9 is 0, then that will give us a solution to the equation. And if 4b squared minus 11 is 0, that'll give us a solution to the equation. So solving here, we have b is equal to 9. If b is equal to 9, then that makes this orange expression 0, which makes the equation true, because 0 times all this stuff would be 0. So now I'm going to solve this equation. This is an equation with the square. So remember, when you solve an equation with the square, you have to isolate the square. It's not isolated because the 4 and the 11 are next to it, so I'm going to add 11 to both sides. Then I'm going to divide both sides by 4, and you get 11 over 4. Then I'm going to get rid of that square on the b squared by square rooting both sides. That's the opposite of squaring. Remember, you always have to put a plus or minus. And I know what you're thinking. You're thinking, this is too much. I can't remember all this stuff. Well, yes, you can remember all of it. There are millions and millions of students every year that remember all this stuff. And there's millions and millions of engineers and scientists around the world that remember all this stuff. So you can do it. Okay, so now we end up with b is equal to plus or minus root 11 over 2. So those are 2 solutions to that equation. And again, I'm not going to show how to go from here to here. That's all stuff that you learned in after test number 2. So now we have an equation with the square. Isolate the square, and then square root both sides, remembering to put a plus or minus on the side opposite the variable. Try number 20. When you come back, we'll do it together. All right, we're back. So I'm going to subtract 3 from both sides, and I'm going to multiply both sides by 5. And then I'm going to divide both sides by 7. And I did it. I isolated the square. The square is now by itself on the left side of the equation, 9x minus 2 squared. So now, after isolating the square, I want to get rid of that square, so I'm going to square root both sides, which is the opposite of squaring. And remember, whenever you do that, you have to write a plus or minus. So that gets rid of the square on the left side of the equation. So now we have 9x minus 2 is equal to plus or minus root 15 over 7. Now, we can't have the denominator under the root. So we have to change that to root 15 over root 7. And again, be aware that you can do a lot of these steps here in your head that I'm about to do. I want to multiply both sides by root 7, and we get root 105 over 7. At that point, we just have to solve for x, and then we'll be done. But this can be kind of daunting. Add 2 to both sides, and again, you can put the 2 on either side. Doesn't matter. Now we're going to divide both sides by 9. Now this is the part where students are really going to get freaked out here. This is actually going to become a complex fraction. So this problem is becoming kind of nasty. So we have that complex fraction there. Whoops, I forgot to erase that 9. This 9 not going to be there. So I'm not going to make you simplify this complex fraction. Yeah, it's just too much work to have to do right now. The point of the problem is to just learn how to solve the equation with the square. We pretty much solved it. But just in case you want to know the fast way to solve it, I didn't teach you the fast way because, again, it's hard to understand. But if you multiply both sides by 7, the numerator and the denominator, this will become 14. That fraction will go away. The denominator of the fraction will go away. So I multiplied the top by 7. Multiply the bottom by 7, because if you multiply the top by 7, you have to multiply the bottom by 7. You end up with 63, so that would be the solution. But again, I'm not going to require you to do that because we didn't learn that fast method. So that solution there boxed is fine for now. I'm not going to make you do that on the test. All right, number 21. We have an equation with a fraction, and we have to get a common denominator for all these fractions. And to help us get a common denominator, we're going to factor that expression there. That's calling out to you. It's calling out to you to factor that. So go ahead and do that, and when you come back, we'll do it together. All right, we're back. So I'm just going to rewrite these fractions, and then I'm going to factor that quadratic, because again, that's calling out to us to factor that. And what two numbers multiply to -6 and add up to -5? That's going to be -6 and +1. So now that helps us understand what we have to do to get a common denominator. I'm going to multiply both sides of this fraction by x plus 1. And I'm going to multiply both sides of this other fraction by x minus 6. So those two fractions will now have the same denominator. And this already has that expression in the denominator, so I'm just going to leave that. And so now I'm going to distribute. So we have 3x plus 3. And we have x minus 6. And again, we can just rewrite this expression. So now you see we have common denominators. And I'm just going to double check everything. Everything looks right. Now we can combine these two fractions. 3x plus x is 4x. 3 plus -6 is -3. So I just combined those fractions. The reason that I could add those fractions is because they have common denominators. So now we're at a very critical stage. It's very important to understand what's going on here. We have two fractions that are equal to each other, and the denominators just happen to be the same. So the only way that these fractions could be equal is if the numerators were equal. So that principle helps us solve this equation. Subtract 2x from both sides, add 3 to both sides, divide both sides by 2, and you get 6. So we're done. We found the solution. Actually, we didn't find the solution. Because look at this. If you plug this 6 back into here, what happens to that denominator? That denominator becomes 0. So you know what that means? X is not equal to this 6. And you can just say no solution. So I know what you're thinking. You're thinking, we had to do all that work just to find out there's no solution? Yes, we did. But at least we found out there's no solution. Okay, so now let's try number 22. Again, we're going to have to factor. So try this problem. If you can do the problem on your own, go ahead and try it. Stop the video. Don't just let me do it for you. We're going to factor. We have a GCF that we can factor out, greatest common factor, and that's going to tell us how to find our lowest common denominator. So I'm going to take this first fraction and I'm going to multiply by x. I guess I can put dots there just to show what we're doing. And I don't need to do anything on that middle fraction because it already has a common denominator. I'm going to take this other fraction on the other side here and multiply both sides by x plus 2. And then I end up with negative x over x times x plus 2 minus 3 over x times x plus 2 is equal to, I don't really need parentheses in the numerator, x plus 2 over x times x plus 2. Now why is this significant? It's significant because I now have common denominators. See, these yellow denominators, they're all the same. That's why I did that. Okay, so at this point, this is a good point. Just go back over and see if we did everything correctly. Looks like we did. So now we have common denominators on the left side of the equation, so we can go ahead and combine those fractions. And now, again, it's very important to understand where we are at this point. We have two fractions that are equal to each other, and the denominators are the same. So that means that the only way that the fractions could possibly be equal is if the numerators were the same. Add x to both sides, subtract 2 from both sides, and we get negative 5 equals 2x. And divide both sides by 2, and x is equal to negative 5 halves. Now, is that an extraneous solution? Well, if you plug in negative 5 halves to these denominators here, you're not going to get 0, so you know that we don't have to worry about that being an extraneous solution. So if you got that answer, good job. As you can see, these problems are pretty involved, but we've done these problems before. If these problems seem very unfamiliar to you, then that means you haven't been doing the homework and going along with my classes. So go ahead and try to solve this problem, and when you come back, we'll do it together. All right, now this expression is calling out to us. That's a quadratic, so it's pretty much a dead giveaway that we're going to have to factor that. What two numbers multiply to 12 and add up to 7? That's going to be 3 and 4. So all we did in the first step is factor that quadratic. That's all we did. That's going to help us see how to get a common denominator. So then I'm going to rewrite that. And I'm going to multiply both sides of this fraction by x plus 3. And remember, you must put parentheses here. A lot of students don't put parentheses there. That's incorrect. These parentheses here, I'm talking about these parentheses here, you must put parentheses there because you're multiplying x plus 3 times the whole thing, not just 4. And you must put parentheses around the x plus 3 in the denominator. I'm going to multiply both sides of this fraction by x plus 4. And why did I do that? Well, because now we have common denominators. And again, you must write parentheses around the x plus 1 when you're multiplying it by something. So just double checking everything there. That looks correct. So then we have, just going to rewrite this. We have x plus 3 over that common denominator. Now, at this point, you see this purple expression here. You can do that in your head. You're going to have to FOIL that. And I know what you're thinking. FOIL? We have to FOIL? That's ridiculous. This is getting too complicated. Well, stop complaining and just do it. I bet you $1 you could do that in your head. FOIL that out. First terms, f, and then o and I, they add together to get 5x, and then 1 times 4 is 4. So x squared is f, o is 4x, I is 1x, and L is 4. Add the 4x and the 1x to get 5x. Now, again, that might seem pretty complicated to do that in your head, but it's really not. I mean, it's not that difficult. Have confidence in yourself, and you can do that in your head. If you want to do it step by step, then you can go off to the side over here and do the math. But it's really easier to just do it in your head. You're going to have to get used to that eventually. At this point, you've multiplied binomials so many times that you need to start getting to the point where you're confident skipping some steps. So the only steps that I really skipped there, because I didn't really skip a lot of steps. You think that I skipped a lot of steps there, but I really didn't. All I did was just add the O and the I term together. I mean, it's not that big of a deal. When you start going into upper math courses, you're going to become more and more confident doing that in your head. Now, it's very important to understand that all of this stuff changes sign because you're subtracting that entire fraction. So now we're going to combine these fractions because we have a common denominator. All these terms are positive, but because you're subtracting that fraction, they're all going to change to negative. So I'm purposely taking an intermediate step just to show you that. So we have negative x squared minus 4x minus 1. So again, it's so important to understand where we are at this point. We have two fractions that are equal to each other and the denominators are the same. So the only way that that could possibly work is if the numerators were equal. It's also extremely important to understand that this is a quadratic equation. It doesn't look like a quadratic, but it is a quadratic. If you put everything on the right or the left side of the equation,
and so now it's in standard form, and we can use our special method to solve this equation, factoring. What two numbers multiply to 4 and add up to 4? Two numbers that multiply to 4 and they also add up to 4. Well, if you said 2, you're right. So plus 2 and plus 2. And so what that means is that x plus 2, if that's equal to 0, then the equation will work. But if x plus 2 is equal to 0, that will also work. But of course, that's kind of dumb because they're both the same. So you can just say x is equal to negative 2. So if you got that answer, good job.
Now remember, we always have to check to make sure we don't have any extraneous solutions when you have equations with fractions. If you plug in -2 to these denominators, you're not going to get 0 in the denominators. -4 or -3 would make 0 in the denominators, but not -2. So -2 is a solution, and we don't have any extraneous solutions. So now we have equations with square roots. And, I'm going to switch these around. I'm going to do this problem first, because this problem only has one square root. So when you have one square root, you want to isolate the square root, but the good news is it's already isolated. It's already by itself. So now we can just go ahead and square both sides of the equation. All right. And I think I'm going to color that square operation. I want to highlight what's happening here. So now squaring gets rid of the square root, so now we're just left with -4x plus 9. So things are getting more simple on the right side of the equation. But over here, this is where students have a lot of trouble. The most common mistake that students make is they say, oh, that's equal to x squared minus 1 or plus 1. It's not. All right? One of the most common mistakes that students make is thinking that a plus b squared is a squared plus b squared. Not correct. Not even remotely correct. All right? What you have to do is, when you square something, what you're doing is you're multiplying it by itself, you see. But here, you have to use FOIL. Now, again, don't complain that you have to use FOIL. Just get it done. F is x times x. O is x times -1, which is negative x. I is -1 times x, which is negative x. And L is -1 times -1, which is positive 1. So we FOILed that out. We multiplied the first terms, we multiplied the outside terms, we multiplied the inside terms, and then we multiplied the last terms. That's FOIL. And if you want to, you can even combine these terms in your head if you want to skip a step. Okay, so at this point, we have a quadratic equation. It just doesn't look like a quadratic equation because it's not simplified and it's not in standard form. So what we're going to do is put everything on the left side of the equation, and we end up with the following equation. That's a quadratic in standard form, and you know what to do. What two numbers multiply to -8 and add up to 2? That's going to be positive 4 and -2. So what that means is that x plus 4, if we set it equal to 0, we can find the x value that will make that factor 0. And x minus 2, if we set that equal to 0, same thing. So solve the equation, and we have -4. That's the x value you plug in to make it 0. That makes the equation work. X equals 2, that's the value that makes the equation work, so on and so forth. Again, I'm over-explaining this stuff, but you don't have to explain this stuff every time you do the problem. You just do the problem and get it done, you see. So I'm making it seem a lot more complicated than it is because I'm explaining it. All you have to do is know how to do the problem. Now, before we continue here, we have to check these solutions. In fact, I shouldn't rectangle those until we check them. Let's try 2. With these square root problems, you have to check to make sure you have no extraneous solutions. So up here, I'm going to plug in 2. So we have 2 minus 1, and then we have -4 times 2 plus 9. So up here, 2 minus 1 is 2. And if you do the math there, you get square root 1. Oh, whoops. 2 minus 2 is 1. So we end up with 1 is equal to 1 because square root of 1 is 1. So that is a solution. 2 is a solution. Now let's plug in -4. See if that works. So -4 minus 1 is equal to square root -4 times -4 plus 9 you can already see we have a problem here. It's impossible for a square root to be equal to a negative. Because here you get negative 5, and then you get negative 7 in there, I believe. Solution is negative 4. Actually, no, that should be, that's 25. Negative 4, yeah. But again, the square root of a number cannot be equal to a negative, so that's actually an extraneous solution. And I know what you're thinking. You're thinking that's a dirty trick to come up with an extraneous solution like that, but that's how the math works. Sometimes you have extraneous solutions, so we have to write not equal to. So if you got those answers right, good job. If you're just watching me do the problem, that's okay, but again, you want to do as much of the problems as you possibly can. We have one more problem here. The problem is now we have 2 square roots. So this problem is going to be a little bit more involved. We want to isolate the square root, but we can't do that because there's 2 square roots. How do we isolate the square roots? So we have no choice but to go ahead and square both sides of the equation, and at least that'll get rid of the root on the right side of the equation. So I'm going to square both sides of the equation. And again, that gets rid of the root on the right side of the equation. So now we end up with x minus 8. And over here, again, a lot of students would say, you know, it's just going to be x minus 4 or x plus 4 or something like that. It doesn't work that way. That's one of the most common mistakes that students make in the math curriculum. When you square something, that means you're multiplying it by itself. Now you can kind of see where we're going with this. So we're going to have to use FOIL. So we're going to multiply square root x times square root x. And if you do that, you end up with square root x times x. And then, so that's f of FOIL. And then O of FOIL is just going to be square root x times negative 2, which is negative 2 square root x. I is negative 2 times square root x, which is negative 2 square root x. And then negative 2 times negative 2 is 4. That's L of FOIL. That equals x minus 8. X times x is just x squared. And we can combine these. That's just going to become negative 4 root x. The root x's are common, so if you're just combining those, it becomes negative 4 root x. And the square root of x squared, well, that's just x. That just becomes x. And we're just going to rewrite this other stuff. So now, what else can we do to simplify this? We can just subtract x from both sides. So then it just becomes negative 4 root x plus 4 equals negative 8. If we subtract x from both sides, don't these yellow x's just disappear? Now we're going to subtract 4 from both sides. And we have negative 12 over here. Divide both sides by negative 4. And we have root x is equal to 3. So at that point, we found square root x. But we don't want square root x. We want x. So we're going to have to square both sides of the equation to get rid of that square root. Then we end up with x is equal to 9. And before we rectangle that, we have to see if that's an extraneous solution. So now let's plug it in and see if it works. So the square root of 9 minus 2 is equal to square root 9 minus 8. So I plugged in 9 for x. So let's see if it worked. Square root of 9 is 3, and 9 minus 8 is 1. So 3 minus 2 is 1, and the square root of 1 is 1, so that worked. 1 equals 1. So that is not an extraneous solution, so we can go ahead and rectangle that. So that is the class today. Now, if you know what you're doing, then the test is going to go a lot faster than that. So if you're thinking, that took too long, I don't have the energy to take a test that takes that long, well, it's not going to take that long. If you know what you're doing, you can skip some of these steps, and you're not going to have to explain it to somebody. You're just going to do it much quicker. So if you want to take screenshots of all the work that we did to help you with your practice test, your homework, go ahead and take a screenshot. That's screenshot number 1 and screenshot number 2 and screenshot number 3 and number 4 and the next screenshot and the last screenshot. Now don't go before you get your homework. Let's take a look at the homework. We have another practice test to do for your homework. Again, it's not going to take as long as it took. That's screenshot number 1. It's not going to take as long as it took for me to do that because you're not going to have to explain every problem necessarily. Screenshot number 2, screenshot number 3, screenshot number 4. Now, it is true that the studying does intensify. Screenshot number 5. When you're studying for a test, it does intensify, so don't complain if you're having to study hard. And last screenshot here. You are going to have to study hard for this test. Here's the answers. Don't forget to get the answers. It's not enough just for you to attempt the practice test. You have to get all the right answers. So you might have to look back at your notes, the screenshots from my classes, your homework, to figure out how to do these problems. But that's just the way it is when you're studying for a test. Sometimes the work intensifies because you have to review everything that you learned in this class, at least in the last 4 or 5 classes. You have to review that stuff. So get that homework done, and do not go on to the next class. Do not take the test, test 3, unless you've done this entire practice test, every problem, and unless you have the right answer for every problem. And I'll look forward to seeing you in the next class.